XL 2 pi FL 2 pi times 50 times 120 times 10 to the minus 3. That equals 12 pi ohms, which is 37.70 ohms. That's the first part, and I think we all eventually got that far. XC, these two formulas are completely different. 1 over 2 pi FC. 1 over 2 pi times 50 times 100 times 10 to the minus 6. Is it 100 or 120? 100. That comes out at 31.83 ohms. I think we all got that far. Yeah? Then, remembering what we're aiming for is to be able to find the total impedance Z so we can find the current. So, we've got this formula Z is equal to the square root of R squared plus the difference between XL and XC all squared. That was on the last 2 pages that I done on the board before I give you this problem. R is 5 ohms. XL is 12 pi. XC 31.83. All that squared. 7. And what I got? Oh, hang on, this is 7.71 ohms. Yep. So now that we've done all of that, we can find what the question was asking for in the first place, because I was Vs over Z, which is the 300 volts over 7.71 equals 38.91 amperes. So that's the answer to A. Yeah. B, the phase angle can be found from tan to the minus 1 of the overall reactance. The overall reactance, remember, is XL minus XC over the resistance. That's tan to the minus 1 of 12 pi minus 31.83 all over the resistance 5. Anyone got an answer for that? .57 degrees. Alright? Now, the next bit is a bit tricky because what we've got is we've got the coil is the inductor and the resistor in series. So what we need to do here is find, so this is part C, Z coil is equal to R squared plus XL squared. That's the impedance of just the coil, which is a resistance and an inductor in series. So that is 5 squared plus 12 pi squared equals Someone push those buttons, please. 5 squared plus 12 pi squared. Nope. Square root of 5 squared plus 12 pi squared.
What's the difference between that equation and the last one where we did the difference?
If you do the difference, you're including the capacitor. Here we want the impedance of just the resistor and the inductor. We're talking about a coil of wire. Yeah? That coil of wire has got inductance, Jake? It's got inductance in henries and the resistance of the wire. So you represent them as a resistor and an inductor in series. Yeah, but we're now calculating the tilt impedance of that inductor and its resistance in series, which is a complex quantity.
This equation is going to be 11.9.
That's 38.03. There you go. Like perhaps on your calculator you have to do that. Alright, so now V coil can be calculated from I times Z coil. The current we calculated at 38.91 amps. 38.03 ohms equals 1480 volts. Series RLC circuits can be a danger. We're applying 300 volts and we got 1480 volts across a coil.
That's a lot of volts.
Yeah. 38.91 was the current I, calculated in part A. No, the current I in part A. Let me go back to my calculation. Right, summary. We calculated XL and XC, put them in that formula to get the total impedance, used that to calculate the current, which is what I was asking for in terms of A. 38.91. Here, we're calculating Z coil, which is V coil, which is I times Z coil, 38.91 times 38.03, 1480 volts. And then D, the capacitor is I times XC, that's 38.91 times 31.83 equals 1239 volts. Okay. Alright. We'll call that a day there, and we'll deal with RL parallel circuit and solving problems graphically at the beginning of next week's session. Alright?